everyone, I hope everyone is safe and doing good. Welcome back to my channel Trick or Treat with Mathematics. So far we've seen whole numbers. We have seen the introduction to whole numbers. We've seen importance of zero, and also we've covered the representation of whole numbers on the number line. In today's video, we will be seeing the closure property of whole numbers. This video is completely about closure property, just to make you understand what exactly a closure property means. And then we'll delve into the operations that can be performed on using the closure property on whole numbers. Let's jump right into the topic of the day. So let's start today's video by seeing what happens if I tear a page from this book. I'll just tear one page from this book. Will it still be a book? Of course it can be. It will be a book, because I'm tearing only one page from this 300 to 400 page notebook. What if I tear two pages from this 300 and 400 page notebook? It will still be a book. But what if I tear all the 300 pages from this notebook? Given that this is a 300 page notebook, it then stops to be a notebook. What if I add one page to this notebook? It's the opposite of what I've been saying. If I add one page to this notebook, it will still be a notebook. And if I add multiple pages to this notebook, it will still be a notebook. It will never stop being a notebook. That is nothing but closure property of whole numbers. I guess you're confused now. In short terms, closure property means if we add or subtract a number, we should get the number belonging to the same set. Here set means if we are adding two whole numbers, we should get a whole number. If we are subtracting two whole numbers, we should get a whole number. You will ask me a question. How is this related to this book operation? It is related because I am tearing a page from this book. A page, as in one page from this book. But it didn't stop from being a book. It's still a notebook. So that means we are subtracting one page from this notebook. So it is still a notebook. Right? So that is nothing but closure property. We are adding one page to this notebook, and we'll ultimately get the result as a notebook only. Right? You will throw your shirt for washing, and once you wash that shirt, you will still get the same shirt after it dries away. Right? You are just getting a clean shirt. That is nothing but we are ultimately performing one operation on a set, on a shirt, or on a book, or in our case on a set of numbers. We will get the same result. Same set of numbers towards the end. That is number belonging to the same category of numbers. So this is the meaning of closure property in real life. This is what will apply in today's lecture to all the operations that we know in the number system, that is addition, subtraction, multiplication and division. This closure property is applicable to all the number systems that we have learned so far, and we will be learning in the future. So remember this concept, and let's use this concept wherever necessary in our future videos, that is for integers, for rational numbers, for real numbers, etc. But the meaning of closure property remains the same. Okay, now let's jump right into the closure property on whole numbers as a part of our whole number series today. So now, after the introduction to closure property, I hope you understood the property. So now let's start with how to represent the closure property under addition, and how to see whether this satisfies for the whole numbers, addition of whole numbers. Now, closure property of whole numbers under addition says that if you add two whole numbers, okay, you need to get a whole number only as a result. If you get anything but a whole number, then the closure property is not satisfied. Okay, for example, let's take, you know that whole number starts from 0. So let's take 0 and let's take 25. This is a whole number and this is a whole number. Here our set, that is our collection of numbers, that is our topic today is whole numbers. So our set, our elements that we take or our addends that we choose or the numbers that we choose to add should be of whole numbers only. Okay, so whatever you choose to add should not be integers or any other. It should be whole numbers. Then only we can see whether this property is satisfied for addition of two whole numbers or not. So I have taken 0 and I have taken 25 from the set of whole numbers. You know that whole numbers, they start from 0, 1, 2, 3, 4 and so on up to infinity. Right? And what if we add 0 and 25? What is 0 plus 25? We get 25. Right? So this is nothing but, is this not a whole number? It is a whole number. So the closure property says that when you add two whole numbers, you will get a whole number. And we are getting in this instance. Try adding any number for that matter. If I try adding 24 plus 20, I am getting 44. 44 is a whole number. Right? If I add 2 plus 9, 9, 9, 9, 9, I'll get what? 1,01,000. This is also a whole number. It falls in this range. Right? So that means whole numbers, the closure property of whole numbers for addition is always satisfied. That means if you add two whole numbers, you will get the result as a whole numbers. That is, for addition, the whole numbers is closed. Okay, that is the meaning. So, I am not sure if you are introduced to algebra yet or not, but we have a definition of closure property. In all the textbook is the same definition, but just to introduce you to that definition, I would like to tell you a few things if in case you are unaware of using a variable. Okay, so for example, we have A and B. Okay, you know that A and B are alphabets, right? Assume, again I am using the word, assume A and B as numbers here, that is whole numbers here. Okay, so if A is a whole number and B is a whole number, that means A and B can take any values in the whole numbers range, that is this set. Okay, so if A is a whole number and B is a whole number, then A plus B is also a whole number. This is nothing but closure property of whole numbers. You understood? So if A is a whole number and B is a whole number, then A plus B is also a whole number. And here A and B are just representation of two whole numbers. Representation as in is we are just assuming A and B as whole numbers. We are just thinking that A and B are whole numbers. So these are nothing but this, whatever we have done is here. A is 24, B is 20 and it's a whole number. A plus B is this one. So this will be what? A, B and A plus B. Okay. So you can say the whole numbers are closed under addition. Use the word closed. That means if you add two or more whole numbers, you will get the whole number only as the answer. Okay. So this is nothing but the closure property of whole numbers under addition applicable to all the whole numbers. Let's see the closure properties of whole numbers under subtraction. Know that when 5 is subtracted from 2, you get 3. That is, subtraction is nothing but difference, right? Now, if we want to apply closure property on subtraction, it will work, but at the same time, it might not also work. It is not always closed under subtraction. That means whole numbers are not always closed under subtraction. So that means in general you can say whole numbers are not closed under subtraction whenever we have A is less than B. Why only this condition, you might ask? Let me give you a few examples, then you'll understand why. Suppose, for example, I take here A, B, A minus B. Okay? And remember, as we spoke in our earlier discussion, whole numbers or the closure property under addition, these two should be whole numbers. Then only we need to check whether this will be a whole number or not. So what I'll do is I'll just say whole number or not as a question. Okay, let's see in what all cases this will not be a whole number. Okay, now for example, I'll take A as 5, B as 3. What is 5 minus 3? 2. Is it a whole number? Yes. Now A as 10, B as 1. What is 10 minus 1? 9. Is it a whole number? Yes. If I take 0 and B as 0, what is 0 minus 0? 0. Is it a whole number? Yes. What is the trend that you are observing here? The trend that you are observing here should be that A is greater than B in all these cases. 5 is greater than 3. 10 is greater than 1. And but here you are saying 0 is equal to 0. Right? And if I say this is 5, you say that A minus B is equal to 0 here and 0 is a whole number? Yes. So, the trend that you are observing here is whenever a number A, in this case, whenever A is greater than B and A is equal to B, then the closure property satisfies for subtraction because we are getting whole numbers in the end. Right? Now, let's see the scenario where A is less than B because we made a statement here that whole numbers are not closed under subtraction whenever A is less than B and B, where again A here and B here are just two whole numbers that we are assuming for the day. Okay, now let's see what happens if A is less than B. What is A here? It is, say for example, we have a whole number 5. What is B here? 7. Is it not A less than B? Right. So what is 5 minus 7? We get minus 2. And minus 2 is not a whole number. Why is minus 2 not a whole number? Because we know that all whole numbers are starting from 0, 1, 2, 3 and so on to infinity. That is, there is no question of negative numbers in whole numbers. In short, so negative numbers are not a part of whole numbers. Only positive numbers are a part of whole numbers. That is the reason when A is less than B, we cannot say that this negative number is a whole number. So hence the closure properties are not satisfied when A is less than B. And let's take one more example. Okay, let's take 1000 here and let's take 10,000 here. Here also A is less than B. We get minus 9,000 as the answer. This is not a whole number because whole numbers start from 0 and not from negative integers. Okay, so that is the reason we can say that whole numbers are not closed under subtraction whenever A is less than B. But we can also say that whole numbers are closed under subtraction whenever A is greater than B and A is equal to B. So in short, when you subtract two whole numbers, you might or might not get the whole number as a result depending on the largest numbers between A and B, whether A is greater than B, A is less than B and A equal to B. Okay, so this is the closure property of whole numbers under subtraction. Now let's see the closure property of whole numbers under multiplication. Now let's see whether whole numbers are closed or not under multiplication. For example, let's try to multiply two whole numbers A and B. Okay, and as I told you, here whole number A can be from the range 0, 1, 2 and so on to infinity, and B also can be of the same range because A and B needs to be whole numbers, right? So what will happen if we multiply A and B? Will we get a whole number or not? In case A and B are whole numbers, let's try to find out. For example, I am taking A, B and A into B. Okay, now let me start by taking the easiest whole number 0. 0 into 10,000 is what? It's 0 only, right? 0 into 1 crore is also 0. 0 into 1, it is 0, right? In the same way, if I take 1 into 25, is it 25? Right. Now I'll say 24 into 3, it is 72. I have used all the combinations here, if you see. Now let's take another scenario. That is 1 into 1, nothing but 1, right? So now I've taken all the scenarios where A is less than B, right? A is greater than B and A is equal to B. In all these scenarios, if you perform the operation multiplication, then we are getting a whole number at the end. These are all whole numbers, right? 0, 25, 72, 1, all these are whole numbers. So you can confidently say that whole numbers are closed under multiplication. That means if we multiply two whole numbers, we will get the whole number only as the result. So this is nothing but closure property of whole numbers under multiplication. Now let's see the final operation, that is closure property of whole numbers under division. Now let's try to find out by dividing two whole numbers and see whether the closure property of whole numbers will satisfy for division or not. So we'll take two numbers in the same format as last time and just say A, B and A by B, okay? Now what is A here? Suppose we'll say A here, 2 by 5. Okay. So if you divide 2 by 5, what will you get? You will get a fraction. 2 by 5 is nothing but 0.4. Here only you can say that whole numbers is not, this 0.4 is not a whole number. That means they are not closed under whole numbers. Only a few cases where one is the factor of other or one is the multiple of other, then it will suffice. For example, if we say 6 here, 3 here, right? So 6 divided by 3, you know, it is 2. Then it is a whole number, right? And again, if you say 0, 0 divided by 5 is 0, then is a whole number. But if I say 7 and 2, 7 divided by 2, sorry, it's a 0. 7 divided by 2 is nothing but 7 by 2, that is 3.5. It is not a whole number, right? So a few cases it is whole number, a few cases it is not whole number. So A divided by B may or may not be closed under division. So this is nothing but the closure property of whole numbers under division. That means when two numbers A and B, that is these two needs to be whole numbers, then A divided by B is not closed. That is A divided by B, and make sure that B is not equal to 0, because B is equal to 0, then we don't have a definite number. So A divided by B is not closed under division. So in short, we can say that for division and for subtraction, closure property of whole numbers doesn't satisfy, but for multiplication and addition, it satisfies. So this is the closure property of whole numbers under division. So with this, we have come to an end of our video. I hope you understood the concept of closure property and how we have applied this property to the whole numbers under different operations. So if you like my video, and I request you to like, share and subscribe to my channel and ring the bell notification down below so that you would never miss an update from me. So in the next video, we'll be discussing completely about commutative property and the commutative property on whole numbers under all these operations. So until then, I'll see you in my next video. Please take care and have a nice day ahead. The puzzle of the day and the solution of the previous puzzle will be as follows. Bye.